What up, ladies and gentlemen? We are taking a look at Unit 2 motorized cart results. We are actually going to do an example off of all those great, awesome vocabulary words we learned in the last video. So you'll see we got an example, we have a graph sitting on over here, a position versus time graph, and then we have a little data table that is going to be explaining the different parts of motion. You'll notice that in this graph right away you see one part of motion between 0 and 20 seconds. That's very similar to our motorized cart lab. We see a nice straight line of a position versus time graph, and then we have something going on between 20 and 30 seconds that's a little bit different than the first 20 seconds. So we will compare those. We will look at distance, displacement, velocity, and speed for all those different time intervals. My suggestion right now is to actually pause the video and try some of these things out yourself. You should be able to do this right now with the given information. We haven't actually done an example problem, but you have enough information to do it. So pause it right now, give it a shot, and then resume it to get the answers. So, for the first 20 seconds, the distance, remember, is how far an object traveled. So right away I'm thinking about this and I'm like, you know what? That's actually, we're starting at 4 meters. And when we get to 20 seconds, we're at 10. So I'm thinking, how far did I travel? Well, and technically all I'm doing is I'm doing 10 minus 4. Gives me a total of 6 meters. Displacement, you're going to notice, is very similar. Displacement is, again, the final position minus the initial position. So in this case, I'm going to take my final position, which is 10 meters, and I'm going to subtract it by 4 meters. And you notice I'm doing the same exact thing that I did for distance, so you're probably wondering, wait a minute, how are these two things different? You're going to see that in just 1 second. Velocity... Velocity in this case, we have the slope of this line. So remember, the slope is equal to our velocity. So in this case, all what I'm going to be doing is I'm going to be taking the rise over the run. I just learned my rise is going to be 6 meters, and I'm going to divide it by the run, which is 20 seconds. So in this case, you will note that, what does this become? 0.3, I believe, meters per second. Let me double check that. 20 times 5 is 100, so 6 times 5 is 30. So, yeah, 0.3 meters per second. And finally, our speed. Speed is the absolute value of velocity for this case, and so this will still be 0.3 meters per second. Notice it's very similar for a lot of these answers, but you will notice the difference between distance and displacement and velocity and speed in the next example. So, okay, taking a look at 20 to 30 seconds. Distance, again, how far did I travel? So in other words, I started at 10, got to 0. You're going to notice that I traveled 10 solid meters. For displacement, this is a little bit different. This is final position minus initial position. In this case, I ended, my final position is 0 meters, and my initial position is 10 meters. So you'll notice that displacement actually is negative 10 meters, telling me the direction I have displaced. So remember, this negative is not referring to a loss. It's just referring to a directional of displacement. Notice that we displaced positive in the first 20 seconds and negative in the last 10. That is a big difference here. Velocity is again the same thing. It is the slope of this line. So remember, the slope is going to be rise over run. I am seeing my rise in this case be, well, it's actually a negative rise, so it's negative 10 meters divided by the 10 seconds, and you'll notice that we are at 1 meter per second there. I'm sorry, negative 1 meter per second. Again, velocity tells us direction. We are moving left in this example, or towards the origin. That's what that negative is referring to. And finally, for speed, you will note that it is the absolute value. It is the 1 meter per second. So again, we see some similarities and differences. The numbers are very similar. The difference is going to be the positives and negatives that kind of fall into play. Velocity and displacement, you should start to kind of get an idea. Talk about direction. So that is the big deal between these two. Distance and speed does not show us any direction. And finally, we take a look at the total distance moving from the beginning, our first time interval of 0 seconds, all the way to 30 seconds. Total distance is going to be pretty simple. It's everything that we've covered. In this case, our total distance is 16 meters. Displacement, again, is final position minus initial position. So I ended, what is my final position at my time interval? I ended at 0 meters. What is my initial position? It is 4 meters. So you'll start to realize that this is even a weirder answer. It is a negative 4 meters. The reason being is that you have displaced negative 4 meters. If we take a look at this, we started here and we ended there. It does not matter what happened in between. The question is, how far did you displace? And from this standpoint, you've only moved yourself 4 meters. And again, it's a negative 4 meters, which tells us in what direction we moved ourselves. So that would be negative 4. Our last piece here, the velocity and speed. One of the biggest things that I just want to mention here is you will note that the beginning velocity between 0 and 20 seconds is 0.3 meters. You'll notice the ending velocity is negative 1 meter per second. There's a lot of schools of thought on this. Some people say, well, let's just average them. But if you take a simple average of this value, 0.3 and 1.1 meter per second, you're going to realize that you are averaging something that takes 20 seconds to something that takes 10. So the weight is not exactly the way that it should be looked at. So you will note that that will not work. Right now, we are actually going to just leave these as question marks. The next video will touch base on this. This will actually be a formula that we will look at. We will also look at some example problems that will really sum up this idea. But the key idea is we actually have to look at an average velocity and an average speed and really understand the difference between these, because they have different directions associated with them. They have different things like that. So stay tuned for that. That'll be something that we will draw up later on. Thanks for listening. If you have any questions about this, please bring those in. We can talk about it tomorrow. Have a good night.